This should be angle B, that should be angle C.
Don't mess up, okay?
That's, hang on drawing this a sec till we're sure I did it right. Give me a minute for that. Okay, does it look like I got the sides lined up right?
Yeah, you did.
Okay. Here's the interesting thing. If all I tell you is angle A, okay, if I tell you angle A, if all I tell you is angle A, side B, and side C, that actually doesn't describe just one triangle in this particular case. If I have this triangle drawn and A is less than B, and this is the information I'm given, if this side is smaller than this side,
Can we put some numbers in before we decide which is bigger and what's smaller?
no, just trust me on this one, Sam, that A is smaller than B. Okay? But if I give you this side, and these two are congruent, this side and they're not, and this angle, I can draw two different triangles. Okay? If I give you a length of B, a length of A, and just this angle, then that could just as easily describe this angle or this angle. So if you're given SSA...
Oh, because they're supplementary?
No, they're not even necessarily supplementary.
Well,
There's
like,
not even a predictable relationship.
No, like whatever, if you're making A equal, like, you know how you redrew A, but
Yeah.
then the angle B is supplementary.
Angle B will be supplementary to this, yes, because they all still have to, well, they all still have to add up to 180. Okay? So, Sam, that's a great question. I'm going to get back to you on that one. I want to double check that. Well, C and B, it depends on the length of A, on the angle size of the A as well. That's a great question, and honestly, I want to work that out with you before I give you a straight answer on that.
Keep me doing that.
Yes. No. All right. So you guys get the idea that it's as if angle C were a hinge, and as long as A is small enough, it could be here or it could be here, and you could still have this angle, length B, and length A be the same. So you could be talking about two different triangles. So when you're given an angle and two sides, bless you, in that order, or going around the triangle, you could be talking about one of two cases. And I think I wanted to use your book's example on this, because if I try to make up the numbers on this, it's going to be bad. Okay, so we're going to find two triangles where...
Wait, so you made the one on the right isosceles by cutting it like that?
Oh, good call.
That's what I was just thinking about. There are two C's now. Two side C's.
Yes.
All
Here's the... Let me, Jesse, let me draw the two triangles separately. Okay? And show the two triangles I'm talking about. Because, yeah, this one over here would be isosceles, but that's not actually the triangle I want to talk about.
Unless people are.
I want to talk about this triangle or this triangle. These two, not this one on the right. Okay, I just want to either talk about the little triangle on the left or the entire triangle, because those are the only two possibilities I get if I give you this angle, length B, or length A. Those are my only possibilities. This one or this one. Okay, and they always look something like that. Alright, and this only happens if this side length is less than this one. If this side is longer, well, then that can't happen that way. We'll talk about that a little more tomorrow, I think, at this point. But the two sides here, I want... does the book do it that way? No. Okay, I gotta change this a little bit. I want to talk about when A equals 12. Okay, that actually works. B equals 31. And angle A equals 20.5 degrees. Okay, now I'm going to move over here.
Wait,
Right.
Are you sure you want to do that? I mean, are you sure you want to give us angle A and side A?
Yes, because see on my drawing, if you have angle side side in that order, the second side will always be opposite the angle you
Look
were
at
given.
what you were saying earlier.
Oh, that's incorrect. Thank you, Sam.
And I was wondering, like, how are you going to do it?
Yeah, this is angle side. This is angle side side.
Right now.
The way it works. Now it works.
Yeah, I was like, what is he doing?
Thank you. Thank you. Thank you. Okay, so we're given A equals 12, B equals 31, A is 20.5. We got two possibilities. Somebody tell me how we're going to find one of them. Somebody other than Sam. I want to give someone else a chance to practice setting this up. All right, Layla?
With those sides, you could do the Pythagorean theorem.
Not a right
It's
triangle,
not right.
What? Oh.
unfortunately.
Can you do
Nice
this
flashback.
sine A over, or like 20.5 over 12?
Okay, sine of A, which is 20.5 over 12.
And then sine of B, I guess,
Yeah,
over 31.
sine of B, which we don't know,